Okay. Use the properties of logarithms to expand each logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. So what we're going to want to do is use basically these three properties for the most part. And these other guys might creep up also, but mostly these guys. So I start by looking at the argument. So I look right here, and that's a quotient. So I'm going to start with the quotient rule. Which says that we can, in words, split up a fraction by subtraction. And so this becomes the natural log of 4x plus minus the natural log of y. Then I keep looking at the arguments. And so now I look right here, and I've got a product. So the product rule says I can split up a product by subtraction. And so this is going to become, God, not by subtraction. Let's get that right. See, at least you know that I'm not this highly professional YouTube video person. I actually make mistakes. We split up a product by addition. And so this is natural log of 4 plus the natural log of x minus natural log of 5, and we've done what they've asked to do. We've expanded that as much as possible. So continuing on, start by looking at the argument. And again, we're going to start with the quotient rule, because that's what I've got there, a fraction. Which says again that I can split up a fraction by subtraction. And so this becomes log of 100 minus log x cubed. And we're going to do this really one very small step at a time. Then I'm going to look right here at this argument, and we get the power rule. Which says an exponent on the argument can become a coefficient in front. So this becomes log base 10 of 100 minus 3 log x. And I made a slight bobble in my speaking right there when I said log base 10, because I was thinking ahead. Now, looking at this, some of this was a problem in my lab math. Some of you might type that answer in, and it would say it was wrong, because we really haven't done everything we can do. You have to be really observant here and recall that when a log base isn't written, it's understood to be 10. So it's log base 10. And then that 100 is the same thing as 10 squared. And so I really didn't use a rule here. I just made some observations. If a base is not written, it's understood to be 10, and 100 is 10 squared. And now we have those matching bases, and we can recall this property that log base b of b to the x, because they are inverses, they quote-unquote cancel, undo each other. And so this becomes 2 minus 3 log x. And that is the answer. This is not 2 minus 3 negative 1 log x. These are not like terms, so I can't do anything else. This is the answer. Okay, let's do some more of these guys. Same instructions, expand it. So again, I start by looking at the argument. That argument is a quotient. So I will start with the quotient rule, which tells me I can split up a fraction by subtraction. And so this becomes log base 2 of 8x to the 4th minus log base 2, and we'll take an extra little tiny step here, of y minus 1 to the 1/2. Remember, a square root, same thing as an exponent of 1/2. And then the reason why I went to an exponent is because logarithms and exponents have relationships. So anytime I have a radical and I'm dealing with logarithms, I'm going to go ahead and rewrite it with an exponent because logarithms and exponents have a very concrete relationship. Still just doing one step at a time, I'm going to look at this argument right here. And yeah, when you're doing your work on your own, you could take more than one step. Product rule, we can split up a product by addition. So this becomes log base 2, and I'm going to take an extra little step here. Well, no, I won't. I'll wait to the next step. Plus log base 2 of x to the 4th minus log base 2 of y minus 1 to the 1/2. And then I can look at each one of those exponents right there. The power rule, exponents on the argument can become coefficients. And so this becomes, and here's where I'll do an extra little step too. 8 is 2 cubed. Then that 4 can come down in front, and that 1/2 can come down in front. And then my last step that I can do on this, I've got those matching bases. And so because I have those matching bases, they cancel, and so I get 3 plus 4 log base 2 of x minus 1/2 log base 2 of y minus 1. And there's that answer. And again, a lot of people would be tempted to say there's a 7 here, but these aren't like terms, so that's not going to be a 7 there. Okay, last of this variety. Then we'll condense on the next go around. Again, logarithms have a relationship to exponents. So anytime I see a radical, I'm going to rewrite that radical with an exponent. Fifth root, same thing as an exponent of 1/5. And then I'm going to start with my power rule. This is not going to start with the quotient rule, because I start with the entire argument. And the entire argument, ignoring the natural log just for a minute, the entire argument is raised to that exponent of 1/5. So the entire argument is governed right now by the power rule. So, power rule. An exponent on the argument can become a coefficient. So this is 1/5 times the natural log of e cubed over y squared plus 1. Now again, zeroing in on that argument, it's a quotient. Quotient rule. Split up fractions by subtraction. So that's going to be 1/2. And then I very carefully use some parentheses here. That 1/5 is going to be, it's going to apply to the entire result of the subtraction. So I have to use parentheses, brackets, whatever you want, doesn't matter. But that 1/5 has to go times everything. Then the last thing I can do is right here, when we recall that the natural log of e to the x is x, because it really is log base e of e to the x equals x. That you really have got that equal base thing going on. And then because they are inverses, they quote-unquote cancel or undo each other. So I've got that going on right here, that the natural log of e cubed would be 3. And that would be my answer. You could just, the only thing you could do if you wanted to, you could distribute that 1/5 or not. It really doesn't matter. The computer should accept it both ways. If you are ever doing a problem and you really honestly believe you're right, but the computer just wanted it in some slightly different form and they didn't really specify. Now, a lot of the problems in my lab math, they're going to say, answer this way. And when they say answer this way, you need to answer that way. But say something like this, and they didn't really specify distribute the 1/5 or not, and you typed it this way and it didn't accept this answer, it wanted it distributed, you don't need to redo the whole problem. You can just write me and say, hi, this is Polly Noon in your 2 o'clock algebra class, and on problem 12, I think I have it right, but my math lab marked it wrong. And I will look at it, and if it is right, I can adjust your score. So if you ever have an issue like that with the computer, that you think the computer has misgraded something, just write me and I can look at it for you. And if I agree, you don't have to redo the problem. I will just adjust your score. But here's the final answer. And the last thing I should say on this one is that this is the final answer, except for maybe distributing that 1/5, that there's nothing I can do here. There is no rule for addition within a logarithm. And that square is not a square on the entire argument. So there is absolutely nothing else I can do here, because there's no rule for addition or subtraction in an argument, and that square isn't an exponent on the entire argument, so there's nothing left I can do. On the next video, we will go the other way, and instead of expanding logarithms, we will condense them.